So today we will start from electric charges and field. So this one is the first chapter of the class 12. तो इधर पर हम लोग पहले प्रॉपर्टीज ऑफ इलेक्ट्रिक चार्ज लेकर बात करने वाले हैं, ठीक है. सो प्रॉपर्टीज ऑफ इलेक्ट्रिक चार्ज. नंबर 1, इसमें से जो भी प्रॉपर्टी है जैसे यूनिट वगैरह सब कुछ हम डिटेल्स में डिस्कस कर लेंगे. ओके. सो सबसे पहले है एसआई यूनिट ऑफ चार्ज इज कूलॉम. इन शॉर्ट हम लोग सी, कैपिटल सी यूज करते हैं. ओके. नेक्स्ट origin of charge. Origin of charge is basically electron and proton of an atom, and charge of one electron or proton is E is equals to 1.6 into 10 to the power minus 19 coulomb. You have to remember that. Okay. Number 3, the third property is quantization of charge. What is quantization of charge? Any value of charge must be integer multiple of E, one electronic charge. Since one electron or proton cannot be divided further, so any value of charge must be integer multiple of one electronic charge. So any value of charge Q should be integer multiple of one electronic charge E. Okay. So here n is the integer. Okay. That is, you can write it in that form: n equals to Q divided by E. And this is basically, it must be integer. And that n represent number of excess electron or number of lack of electron. In a charged body. Okay. तो हम लोग सपोज एक एग्जाम्पल देख लेते हैं. Is it possible to have 8 into 9 into 10 to the power 19 coulomb charged body? तो सबसे पहले चेक करना पड़ेगा n का वैल्यू इंटीजर है या नहीं. सो n is equals to q divided by e. Okay. Here q is given 9 into 10 to the power minus 19, and you know value of e is always constant, which is 1.6 into 10 to the power minus 19. Sorry, it must be 19. Okay. So it is ultimately 9 divided by 1.6. Okay. And it is nearly 5.625. So you can see this is not an integer. So since n is not integer, it is not possible. Okay. So कोई भी वैल्यू इंटीजर में होना है. 5.6 नंबर ऑफ इलेक्ट्रॉन मिलना पॉसिबल नहीं है, क्योंकि इलेक्ट्रॉन को हम फर्दर ब्रेक नहीं कर सकते हैं. सो अगर हमको इलेक्ट्रॉन चाहिए तो आइदर 5 और 6. It can't be 5.6. Okay. Now, actually n is here number of excess electron और lack of electron in a charge body. ये हम लोग ऑलरेडी इधर पर करेंगे. तो एग्जाम्पल 2 सपोज पकड़ लेते हैं. तुमको पूछे है हाउ मेनी इलेक्ट्रॉन्स आर देयर in a 1 coulomb charge body. 1 coulomb charge body में कितना नंबर ऑफ इलेक्ट्रॉन रहता है. ठीक है. So n is equals to again q by e and we know q is equals to 1 here and e is equals to 1.6 into 10 to the power minus 19. Okay. Right? So it will be 6.25 into 10 to the power 18 number of electrons. So there are 10 to the power almost 10 to the power 18 number of electrons in just 1 coulomb charged body. Okay. And the third property, so we'll come to the third property, which is conservation of charge. Number 3, conservation of charge. We know charge can neither be created nor be destroyed, right? So total charge of a system remain conserved. Total charge of a system remain conserved. तो मतलब क्या हुआ? Total charge of a system remain conserved even after mutual exchange of charge. Between bodies in the system. हम बाहर से अगर कोई भी चार्ज ट्रांसफर नहीं कर रहे इधर पर, सपोज तुम्हारे पास दोनों बॉडी हैं, सपोज दिस वन इज ए एंड दिस वन इज बी. Okay, these are two conductor. Initially they are already charged. Suppose the charge of A is Q1 and charge of B is Q2. Okay, now I am going to connect them by a conducting wire. Okay, once it is connected to that conducting wire, there will be a distribution of charge between this sphere, and after that new charges will be Q1 prime and Q2 prime. Okay. So total initial charge of the system, if you consider a system of these two bodies A and B having total charge Q1 plus Q2, and here after the redistribution of charge it will be Q1 prime plus Q2 prime. So according to the law of conservation of charge, you can write Q1 plus Q2 should be is equals to Q1 prime plus Q2 prime. Okay. For neat or a NEET or some other competitive exam like JEE, you can remember that formula. Q1 prime is equals to Q1 plus Q2 into R1 divided by R1 plus R2, and Q2 prime is equals to Q1 plus Q2 into R2 divided by R1 plus R2. So किसमें कितना चार्ज आफ्टर कनेक्टिंग बाय द कंडक्टिंग वायर किसमें कितना चार्ज जाएगा, that depends on the radius of this sphere. जिसका रेडियस ज्यादा होगा उसमें चार्ज भी ज्यादा आएगा. Okay, so total charge divided by R1 by R2 into R1, total charge divided by R1 by R2 into R2. Okay, इसका डेरिवेशन नहीं चाहिए, जस्ट फॉर्मूला याद रख सकते हो. अभी तो सिलेबस में नहीं है, फिर भी तुम थोड़ा सा एडवांस नीट या जेई के लिए तुम याद कर सकते हो. ठीक है. नेक्स्ट नंबर 3, इधर पर एक स्पेशल केस है. व्हाट इज द स्पेशल केस? इसमें क्या होगा? If two charges are identical, total charge will equally distributed between them. मतलब सपोज दोनों स्फीयर, दोनों का रेडियस सेम है एकदम, एंड इनिशियली एकदम आइडेंटिकल शेप का है. इनिशियली इसमें चार्ज था Q1 और इसमें चार्ज था Q2. दिस वन इज A, दिस वन इज B, एंड आफ्टर this one is A, this one is B, and this is Q1 and this is Q2. If you connect it, we are conducting with a conducting wire, then new charges will be Q1 prime, Q2 prime, and which is equals to total initial charge Q1 plus Q2 divided by 2. So total initial charge is divided equally between these two bodies, A and B. समझ में आया? तो फिर हम इस एप्लीकेशन का ऊपर एक एग्जाम्पल देख लेते हैं. ठीक है. सपोज we have two identical equally charged sphere of charge Q. Charge sphere A and B having charge Q. Now, an uncharged sphere is touched with A at first, and after disconnection it is touched with B. Find final charges of the sphere, of all the sphere. Okay. Now an uncharged sphere, but that must be identical. ओके तो पहले इधर पर समझ लेते हैं क्या बताया है। पहले से हमारे पास दो चार्ज स्फीयर है ए एंड बी व्हिच आर आइडेंटिकल इन शेप। इसमें Q1 Q चार्ज है, इसमें भी Q चार्ज है। एंड अनदर अनचार्ज स्फीयर C which is uncharged. At first, that uncharged sphere is charged with A. So then, charge will be redistributed between A and C equally as they are identical. So A and C are connected. So new charges of A and C will be Q plus 0 divided by 2. That is Q by 2, and B charge of B remains same. In the third step, now the sphere C is separated from A and now it is charged with B. So charge of A remains same, which is Q by 2, but now C is charged with B. Right? So previous charge of C and B are Q by 2 and Q, and that whole charge is distributed equally between B and C. So QC prime QB prime is equals to this. That means 3Q by 2 divided by 2, that is 3Q by 4. So final charges are Q by 2, 3Q by 4 and 3Q by 4. These are the final charges of these three spheres. Okay. So in the next we'll come to the next property of charge. Number 4 is induction of charge. Suppose we have an uncharged conductor, okay, having charge uncharged, it is initially uncharged. Now uncharged conductor, and you know there are free electrons in uncharged conductor, okay. Now if you put a positively charged body near to that uncharged conductor, due to the electrostatic attraction, electron will come to that side as they are free to move, okay, and positive charges will come to the other side due to the electrostatic repulsion. Actually there is no positive charge. Electron from those atoms will come from that side to this side, so there will be lack of electron in that side, so which is ultimately positive due to presence of excess proton in that atom, okay. So this is called induced charges. Induced surface charge, okay. Total induced charge from the conservation of energy, you can see if initial charge of that system is 0, that final charge will also be 0. So total induced charge will also be 0. So that's why there should be equal charges on both sides, equal and opposite charges on both sides in order to get total 0 charge. Number 5, there are different way of charging. Different way of charging. इसमें से आता है by conduction, by rubbing to object, and by induction. By conduction is the easiest method. If a charged body is taken in physical contact with an uncharged body, then charge will be distributed between them. Initially it is uncharged, and when it is in contact with that charged body, total charge will distributed between them. Okay. Next one is by rubbing to object. Suppose you have a glass rod and a piece of silk. Okay. And if you rub them, some electron will transfer from glass to silk. So glass rod will be positive, and this piece of silk become negative. Here total initial charge is 0, so charge on both the objects should be equal in order to keep total charge 0. Okay. And the third technique is by induction, and it is little bit different. Suppose you have a charged conductor. Okay. In the next, a charged body is taken near to that charged conductor. As I told earlier, due to induction, there are negative charges on that surface, and due to the electrostatic attraction and due to the electrostatic repulsion, positive charges are on the opposite side. Okay. Now at that situation, if you connect that sphere with the ground means it is infinite source or sink of charges. If you connect that body with ground, then positive charge will move away and it will move to ground due to electrostatic repulsion, and negative charges will be there. Now in the fourth step, I am going to remove that earthing connection. So after removing the earthing connection, there are only negative charges on that surface, and when that charge body is removed, that negative charges will distributed equally on that sphere. So by this method, a body can be charged. Okay. In the sixth property, I am going to discuss about the detection of charge. And there is a specific device for detection of charge which is called gold leaf electroscope. Okay. So at first we have to understand what is the construction of gold leaf electroscope. So here we have a conducting table, and that conducting table is connected with a conductor, a vertical conductor, and at the end of the conductor there are two gold leaves. Okay. There are two gold leaves like this. Like this. Now, and that whole thing is enclosed in a transparent container. Now, when a charged body is taken near to that conducting table, due to induction, there are negative charges on that table which are induced, and these negative charges come from the other side of the electroscope, which is basically gold leaves. So gold leaves become positively charged. This is also induced charge. Okay. Now these two gold leaves will be repelled each other due to like charges, and that's why it will start to open like this. Okay. So from the movement of these gold leaves, you can conclude that that body which is taken near to the gold leaf electroscope must be charged. Okay. So this is the basic construction of gold leaf electroscope. तो हम लोगों को क्या पता है कि दोनों लाइक चार्ज अगर हम पास में लेके आते हैं उसमें रिपल्शन होगा, अनलाइक चार्ज अट्रैक्शन होगा. लेकिन ये जो फोर्स ऑफ अट्रैक्शन एंड रिपल्शन कितना स्ट्रांग है वो भी पता करना है. ठीक है. एंड ये हम लोग नेक्स्ट टॉपिक में चलाएगा which is Coulomb's law. So it is basically, it provides force between 2-point charge. It provides force between 2-point charge. So according to the Coulomb's law, suppose we have 2-point charge Q1 and Q2, and they are separated by a small distance r. Okay. They are separated by a small distance r. Now, according to the Coulomb's law, that force of repulsion between these two charges or force of attraction between two charges is directly proportional to product of their charges, that means Q1 into Q2, and inversely proportional to square of the distance between them, which is smaller. So 1 by r square. Okay. And F is directed along the line joining two point charges. And this is very similar to Newton's law of gravitation, where you can see F is proportional to m1 m2 divided by r square. And here F is equals to q1 F is proportional to q1 q2 by r square. Okay. Okay. At first, if charge is directly not mentioned, all charges are positive. You have to consider all charges are positive. So in this figure, there will be mutual force of repulsion. So q1 will try to move away from q2 and q2 will try to move away from q1 along the line joining two point charges. So these are the force. And this force is called F12, force on q1 given by q2, and this force is called F21, force on 2 given by q1. Okay. And these forces are equal in magnitude. That is, F21 is equals to F12 is equals to F, and which is equals to a constant which is proportional to q1 q2 divided by r square. Okay. Now if we replace this proportional sign to an equals to sign, then there must be a constant, and that constant is called Kc or Coulomb constant here. So Kc into q1 q2 divided by r square. Okay. And that Kc is actually 1 by 4 pi epsilon naught. This is called epsilon and this is naught. So epsilon naught q1 q2 divided by r square. So this is the basic formula of Coulomb's law. Okay. Now Kc is equals to, there is a specific value, Kc is equals to 9 into 10 to the power 9 Newton. This is a constant, but it have unit, and that unit is Newton. If you multiply, if you keep that Kc on this side, it will be F r square divided by q1 q2. So that means Newton meter square kg to the power minus 2. Sorry, Coulomb to the power minus 2. In case of gravitational constant, it will be kg to the power minus 2. In case of Coulomb constant, it is Coulomb to the power minus 2, called Coulomb constant. Okay. And epsilon is equals to, epsilon naught is equals to 8.854 into 10 to the power minus 12 Newton inverse meter to the power minus 2 Coulomb square, called free space permittivity. These two values are applicable only for air medium or vacuum medium between two point charges. In case of other medium, you have to put Kc 1 by 4 pi epsilon naught, epsilon, where epsilon is permittivity of the given medium. Okay. If you compare Coulomb's law and gravitational law, then Coulomb force, constant of the Coulomb force K is of the order of 10 to the power 9, and constant of gravitation, Newton's law of gravitation, is order of 10 to the power minus 11. So you can see the Coulomb constant is much greater than the universal gravitational constant. So that's why electrostatic force between two point charge is much greater than the gravitational force between two point charge, especially for two electron or one electron or proton. Okay. From here, F21 vector is equals to minus of F12 vector, that is, they are equal and opposite. They are equal and opposite. That means that is it follow law of Newton's third law. Okay. Now vector form of Coulomb's law. Suppose there are 2 point charges Q1 and Q2, and position vector of these two charges, that means distance of the Q1 from origin, is provided instead of distance between 2 point charges. So these are position vector. Okay. So in order to use Coulomb's law, you have to find the distance between Q1 and Q2 at first. So you have to find that distance. Suppose this is R12 and it has a direction along that line Q1. So this is R12 vector. Okay. Now from the triangle law, you know, sum of vectors in the order, that means R2 and R12 which are in order, should be equals to the third side in the opposite order here, which is R1. So R12 vector is equals to R1 vector minus R2 vector. This is basically vector subtraction. Okay. And an unit vector represent only direction having unit magnitude, and R12 cap provide direction of R12 vector. So which is equals to R12 vector divided by R12. Okay. That means R1 vector minus R2 vector divided by R1 vector minus R2 vector and its mod. So now force on Q1 given by Q2. Suppose we are interested on force on Q1 given by Q2. So that should be in that direction. That means in the direction of F12, right? So F12 vector is equals to, what you can see, 1 by 4 pi epsilon naught q1 q2 divided by the distance between 2 point charge, that is r12 whole square, into the direction of this force, which is r12 cap. Okay, now I am going to replace r12 cap and r12 by their value. r12 is r1 vector minus r2 vector mod and its whole square, and r12 cap is r1 minus r2 vector divided by r1 vector minus r2 vector mod. So ultimate final expression will be 1 by 4 pi epsilon naught q1 q2 divided by r1 minus r2 mod of cube into r1 vector minus r2 vector. So this is the expression, vector form of force. Basically vector form of Coulomb's law. सो कूलम्स लॉ से हम लोगों को पता चलता है कि only force between 2 point charge, but in a system of charge there may be more than 2 point charges, and that's why there is a principle called superposition principle. Which provide force between 2 point charges, more than 2 point charges. At first, it states that force between 2 point charge will not be affected in presence of force between 2 point charge will not be affected in presence of any other charge. Nearby. दोनों पॉइंट चार्ज में, सपोज इधर पर हमारा तीनों पॉइंट चार्ज है Q1, Q2 and Q3. Now force between Q1 and Q2 will not be affected by the presence of Q3. That means Coulomb's law remain valid in a system of 3 charges also. So Coulomb's law remain valid for each pair. So suppose you want to find out net force on Q1 or net force on suppose Q3. So net force on Q3 F3 vector is equals to sum of two forces. One is given by 1, another one is given by 2. So on the third charge there will be two forces. Okay, if you draw these line joining 2 point charges, and now these are like charges, so they will repel each other. Okay. Now Q3 will try to move away from Q1, so force on Q3 will be along that direction. Force on Q3 given by Q1. Again, to get force given by Q2, you have to draw that line, and Q3 will also try to move away from Q2, so force on Q3 will be along that direction, which is F32. Okay. Now the vector addition of these forces will be the resultant force on the third charge or Q3. So this is not scalar addition, this is basically vector addition. Right? तो सुपरपोजिशन प्रिंसिपल का कोई भी न्यूमेरिकल है तो हम लोगों को वेक्टर एडिशन थोड़ा सा रिकैप करना पड़ेगा, तो हम लोग थोड़ा बहुत जो भी मतलब उतना डिटेल्स में नहीं लगेगा, लेकिन फिर भी हम लोगों को वेक्टर एडिशन थोड़ा सा शॉर्ट में देख लेते हैं. वेक्टर एडिशन, that is r vector equals to a vector plus b vector. Number 1, if a vector and b vector are parallel, मतलब a vector and b vector दोनों सेम डायरेक्शन में हैं, then theta will be 0 degree. As you can see, theta is 0 degree, and then resultant will be just sum of these two vectors, that is r a plus b only, that is normal addition or scalar addition. just addition लिख देते हैं. So this is just normal addition in case of two vectors to be parallel. Okay, and resultant will also along either A or B. Number 2, if A vector and B vector are antiparallel, that means this is A vector and this is the direction of B vector. Then resultant, you can see resultant will be this. So here theta is equals to antiparallel. In case of antiparallel vectors, there will be 180 degree angle. Okay, and this is the resultant R. So here expression of resultant will be A minus B, basically subtraction. We are doing vector addition, but practically it is normal subtraction. Okay, and one another thing what you have to remember, that you have to subtract the smaller vector from the bigger vector. Okay, and resultant will be also along the bigger vector, along bigger vector out of A or and B. ये दोनों में से जो बिगर वेक्टर होगा उस डायरेक्शन में अल्टीमेटली रिजल्टेंट रहेगा. नंबर 3, इफ A vector and B vector are perpendicular, if A vector and B vector are perpendicular, then what you can see, this is the diagram. This is A vector and this is B vector, and resultant will be, what will be the direction of resultant? This is the resultant. Okay. So for theta is equals to 90 degree, resultant will be, it will follow Pythagoras theorem, root over a square plus b square. But in that case, you have to mention the direction of r vector also, which is here angle phi. So tan phi is basically b divided by a, b divided by a, where this is angle of r vector with respect to a vector. Okay. If angle is with respect to a, then a should be at the denominator. If you want to find out angle with respect to b, then b should be at denominator and a will be at numerator. Number 4, for arbitrary angle. For arbitrary angle, r vector is equals to root over of a square plus b square plus 2ab cos theta. Okay, this is normal rule for the vector addition. And you can remember a special case. If a vector and b vector are equal in magnitude, then resultant r will be 2 into a into cos theta by 2. If these two vectors a and b are equal in magnitude, then resultant will be along the angle bisector. This is also a, this is also a, and this is the resultant. This is theta. So this is the expression of resultant. ओके तो ये सब तो बेसिकली ये जो चारों मतलब ये जो देयर आर ऑल दिस फॉर्मूला कैन बी डिराइव फ्रॉम दिस ओके बट अगर तुम इधर से करोगे तो बार बार तुमको बहुत ज्यादा टाइम लग जाएगा सो यू हैव टू रिमेंबर दोस शॉर्टकट्स So in the next we'll come to some example. Okay. Suppose we have 2 point charges. It is given one is 2 microcoulomb, another one is 8 microcoulomb. Which are A and B. And the distance between these two forces, distance between these two charges is 3 meters. Okay. Now, a third charge which is called C, is placed at the midpoint of A and B, which is of 4 microcoulomb charge. Okay. And you have to find net force on C. Net force on 4 microcoulomb charge. Okay. Now I am going to redraw that problem here. This is 2 microcoulomb, 4 microcoulomb, 8 microcoulomb, and leveling are A, B and C. Distance between A and B is 3 microcoulomb, 3 meter. So distance as C is midpoint of A and B, so it is 1.5 meter, and this is also 1.5 meter. Now we want to find out force on C given by A and given by B. So at first, force on C given by A. What will be the direction of force on C given by A? C will try to move away from A as both are like charges. So C is try to move away from A. So force on C will be along that direction. Force on A given by C. And due to B, C will try to move away from B again, as it is also like charge. So that's why it is along the opposite side, which is force A B, direction of force A B, right? So here at first, from the Coulomb's law, we can write force AB is equals to that Coulomb constant Kc into Q1 Q2, right? Q1 is charge of A is 2 microcoulomb, which is 2 into 10 to the power minus 6 microcoulomb. Micro is 10 to the power minus 6, which is not, microcoulomb is not SI unit. So you have to convert it into SI unit. That's why it is taken in coulomb. Micro is 10 to the power minus 6. So 2 into 10 to the power minus 6 coulomb. And charge of B is 8 into 10 to the power minus 6 coulomb. Right? Charge of A and charge of B divided by distance between, sorry, that it will be charge of force on C given by B. Force on C given by B. And this is force on C given by A. Okay. So force of C and B. Force of C is 4. So it should be 4. Now for distance between C and B is 1.5 meters. So 1.5 whole square. Right? And if CA is Kc, charge of C, which is 4 into 10 to the power minus 6, charge of A, which is 2 into 10 to the power minus 6, divided by distance of A and C, which is 1.5 again. Since FCB and FCA are anti-parallel, you can see they are anti-parallel. So net force, what will be the direction of net force? Net force on C is given by bigger minus smaller. So from that you can directly, you can see FCB is greater than FCA, as it is 4 into 8 and here it is 4 into 2. So FCB is greater in magnitude, so FCB minus FCA. So FCB is Kc into 32 into 10 to the power minus 6 into 1.5 whole square, 1.5 into 1.5, and here it is 4 into 2, that means 8 into 10 to the power minus 6. It will be minus 6 into minus 6 minus 12. 1.5 into 1.5. So you can take, and you know Kc is 9 into 10 to the power 9. Okay, Kc is 9 into 10 to the power 9 and 10 to the power minus 12, 1.5 into 1.5, everything can be taken as common. So it will be 32 minus 8. Right? So this is basically calculation. 1.5 into 6 will be 9. So 6 into 10 to the power minus 3 plus 9 minus 12 is minus 3 divided by 1.5 into 32 minus 8 will be 24. Again 1.5 into 4 is 6. So it will be 96 into 10 to the power minus 3 Newton. So this is the net force acting on charge 4 microcoulomb. Okay, and you have to mention, as it is a vector quantity, you have to mention its direction also. FC is along the bigger direction of FC is along the bigger vector FCB, and here you can see it is towards point A. So towards point A or towards 4 microcoulomb charge. You can write that answer like this, और towards left भी बोल सकते हो. In the next problem, everything will be same, but position of C is unknown. Find position of 4 microcoulomb such that it remain in equilibrium. कोई भी चार्ज इक्विलिब्रियम में है उसका मतलब क्या होता है? अगर कोई भी बॉडी का ऊपर टोटल फोर्स, net force on a body is 0, then it is in equilibrium. So position of 4 microcoulomb should be such that net force on it must be 0. So here net force on C must be 0 to be in equilibrium, right? And like the previous case, everything will be same, but the distance between 2 and 4 is taken x as it is unknown. Then distance between C and B will be 3 minus x, right? 4 microcoulomb, that means force on C given by A is along that direction, as 4 will try to move away from A. So force on C given by A will be along that direction. This is on and this is given by. Okay. And force on C given by B, that means force on C given by B is along that direction. If you free to move that charge C, it will move away from B. So force on C will be along that direction. So here again they are anti-parallel. So FC, you can see FCB minus FCA, which is FC is equals to 0. So here FCB must be equals to FCA. If these two forces are equal and opposite, right, then net force become 0. Now FCB is Kc into Q1 Q2. Q1 is charge of C is 4 microcoulomb and charge of B is 8 microcoulomb. Divided by distance between them, C and B is 3 minus x here. And force on C given by A is Kc into 4 into 10 to the power minus C. Charge of A is 2 microcoulomb, 2 into 10 to the power minus 6. Divided by distance between them is x. So Kc will cancel out from both sides. In fact, 10 to the power minus 6, 4, and it will be 4 2s are 8, so it is 4. So 4 divided by 3 minus x whole square is equals to x divided by 1 by x square. If you cross multiply this equation, it will be a quadratic equation and which is hard to solve. So instead of this, I am going to square root on both sides. then it will be 2 by 3 minus x equals to 1 by x if you square root on both sides. Now I am going to cross multiply it. 2x is equals to 3 minus x, that means 3x is equals to 3, that is x equals to 1. So you have to place 4 microcoulomb at 1 meter distance from the 2 microcoulomb charge. So 4 microcoulomb should be at 1 meter from 2 microcoulomb charge. And it is better to write this answer in that form. सिर्फ आंसर ऐसे करके तुम x इक्वल्स टू 1 मीटर छोड़ देने से मार्क्स फुल मार्क्स नहीं भी मिल सकते हैं. ओके Now in the third example, we have a square of side A, and there are plus q, minus q, plus q, minus q. There are 4 charges at its 4 corners of the square. Okay. Find net force on a plus q charge. Find net force on a plus q charge. Okay. तो इसको सबसे पहले A, B, C, D ऐसे करके नेमिंग कर देते हैं. ठीक है, हम ये ऑर्डर में A B C D ऐसे करके देते हैं. दिस वन इज A B C D. So there are, suppose I want to find out net force on that charge. So there are 3 other charges to provide force on A, and we will find each force one by one. So at first you can see force on 1 given by B. This is positive, this is negative. So if you free A to move, it will move away, it will move towards B. So that's why force on A given by B is along that direction, right? Similarly, D is also negative and it is positive, so D will attract A. So if you free A to move, then it will move along that line. So this is force on D given by A. And the third force, which is given by C, if you join that line, A and C, now these 2 charges are like charges. So A, if you free A to move, it will move away from C due to electrostatic repulsion. So this is F A, force on A given by C, right? Now you have to add them vectorially in order to get total force on A. So F dA is equals to F AB, and which is equals to 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught, or Kc, you can write it Kc into Q1 Q2 both are q divided by distance of AB or distance of AD, both are equal, which is A. So it is A square, right? एक चीज तुम लोगों को अच्छा करके देखना है, इधर पर जब चार्ज का हम इधर पर चार्ज बिठाए हैं, हम जो साइन को एक्सक्लूड कर दिए हैं. क्यों? क्योंकि साइन का हिसाब से हम ऑलरेडी डायरेक्शन ऑफ फोर्स दिखाए हैं इधर पर. सो वेक्टर एडिशन उस हिसाब से ही होगा. सो इधर पर साइन लेने का कोई भी मतलब नहीं है. ऑलरेडी डायरेक्शन ऑफ फोर्सेस इज टेकन अकॉर्डिंग टू देयर साइन ऑफ चार्जेस. डी एंड एफ, इधर पर एफ डी एंड एफ बी ए बी आर इक्वल एज देयर Q1, Q2 and R both are same in both cases. Okay? But there will be a difference in FAC. What is the difference? Charges are Q1, Q2, so it will be Q into Q. But distance between A and C is not A. Distance of A and C is the diagonal distance of the square. And we know this is A root 2. Diagonal of a square of side A is A root 2. So you have to take A root 2 and its whole square. Right? Now, if you want to add them vectorially, at first we will take these two forces FDA and FAD. So, resultant of FDA and FAB is, these two forces are perpendicular, mutually perpendicular, and as I told earlier, for two perpendicular vector, formula is root over a square plus b square. So here it is FAB whole square plus FDA whole square, right? And you know these are equal in magnitude, so this is FAB whole square, and if FAB is taken outside, it is FAB into root 2, and we have already calculated FAB is KC Q1 Q2, that means Q square by A square into root 2. Right? Now, this resultant, what will be the direction of resultant? You know, you have to make a rectangle here, which is also parallelogram, and the diagonal of this rectangle will be the direction of resultant. So this resultant F prime, this resultant F prime, इसको F prime नाम दे देते हैं, it is now anti-parallel to FAC. Okay? हम अभी तक सिर्फ दोनों वेक्टर को, दोनों फोर्स को ऐड कर चुके हैं, थर्ड को भी ऐड करना है. एंड इंटरेस्टिंगली इधर पर जो हुआ है, इफ ये दोनों का रिजल्टेंट इसका एंटी पैरेलल हो गया, सो नेट रिजल्टेंट, नेट मतलब सबका मिला के, मतलब तीनों फोर्स मिला के नेट रिजल्टेंट विल बी, ये दोनों को सब्ट्रैक्ट करना पड़ेगा एंटी पैरेलल होने के लिए. तो बिगर माइनस स्मॉलर, इसका रिजल्टेंट में रूट 2 आया है और इसका नीचे में रूट 2 का होल स्क्वायर. सो F प्राइम इज बिगर इन मैग्नीट्यूड, सो F प्राइम माइनस FAC करना है. सब्ट्रैक्शन क्यों हुआ? ड्यू टू एंटी पैरेलल वेक्टर्स. एंड F प्राइम इज इक्वल्स टू, यू नो, KC Q square by A square root 2, and FAC is equals to KC into Q square divided by A root 2 whole square, that means 2A square. So you can take common KC Q square A square, so answer will be root 2 minus half. So this is the final expression of the final expression of the force. तो इधर पर जो भी अलग अलग करके फोर्स मिल रहे हैं उसको क्या करना है, वेक्टरियली ऐड करना है, नॉर्मल एडिशन नहीं चलेगा. फोर्स इज अ वेक्टर क्वांटिटी, तो उसका जो रिजल्टेंट तुमको चाहिए उसके लिए वेक्टर एडिशन ही करना पड़ेगा तुमको. ठीक है. सो नेक्स्ट टॉपिक विल बी इलेक्ट्रिक फील्ड, वो हम नेक्स्ट वीडियो में करने वाले हैं.